Then question number 11. A light string passing over a smooth pulley carries a string balance of mass 1 kilogram and two weights of masses 1 kilogram and 2 kilogram as shown in the figure. The reading on the balance will be, now there is an equilibrium. The string balance is 1 kilogram and there is another 1 kilogram and from it its weight is 2 kilograms. Now we have to get the reading of spin balance. Reading of the spin balance is tension of the cord connected to spin balance. If we are considering correctly, there are two ends for the spin balance. In one end there is a ring like this. In the other end there is a hook like this. The spin balance reading is tension of the cord connected to hook, not ring. But in the given figure there is no a hook or ring. Clearly we can consider this end is the hook. Therefore we have to consider the tension of this end. And when considering equilibrium of this 1 kilogram weight, there are two forces on it, upward tension and downward weight 10 Newton. There is an equilibrium. Therefore we can write tension equals, upward tension equals downward 10 Newton. It is the reading. 10 Newton means 1 kilogram. Therefore answer 2 is correct for the question number 11. Then question number 12. Figure shows 4 coplanar forces A, B, C and D drawn to the scale acting on a point object O. The resultant force R acting on O will most likely to be along the direction. I will try to explain by using a diagram, but sometimes we will not be able to get the correct answer for this question because of we have to consider the original diagram in the paper. This one is a copy. Sometimes it will not get the correct answer, give the correct answer. There are 4 forces. We have to consider resultant force. First of all, I will consider these 2 forces. We have to do this construction in the original paper, not a copy. Then we can complete parallelogram for these forces. And we can get resultant for these 2 forces is in this direction. Now we can remove these 2 forces and we can consider the resultant. And then we can consider resultant force and this force. Then I will draw another parallelogram again. Now it should be like this. The diagonal is in this direction. Therefore we can remove these two forces and we can get the resultant force is this one. And again we have to consider resultant force for this force and this one. We can draw another parallelogram by using these 2 forces and we can get the resultant is in this direction. This is the final answer. This is the resultant of the system. Therefore, we can get Second answer is correct for the question number 12. But they have given fourth answer. There is a difference. It is depending on the diagram. The diagram I have drawn is representing the resultant in direction 2. But in the original paper, the resultant will be 4. Then you have to remember only the method and what should we do for a question like this. We can't get correct answer by using a copy of figure. Then question number 13. An object of mass m is hung by a string and is kept in equilibrium as shown in the diagram by a horizontal force F. The magnitude of F is. Now there are three forces on the object. They have given that this angle is theta. Therefore we can consider that this angle also theta, alternate angle. Now there is a tension in this direction, tension. Weight in downward direction and given F force is in horizontal direction. We have to get the magnitude of F. We can consider horizontal and vertical equilibrium of object. First I will consider horizontal equilibrium. For the horizontal equilibrium, we can write T sin theta. The component in this direction is T sin theta. And in this direction, T cos theta. Now we can remove T and we can consider only components. Then I will consider horizontal equilibrium. T sin theta in left hand direction should be equal to F in right hand direction, first equation. Then I will consider the vertical equilibrium. T cos theta in upward direction should be equal to weight in downward direction, second equation. Now we can divide both the equations. 1 divided by 2. We have to get F value. No. We can consider first equation as the answer. We have to consider only F value. Then F value is T sin theta. We have to substitute T by using second equation. I will subject T from the second equation. mg divided by cos theta. And now I will substitute to the first equation. From first equation, T value is mg divided by cos theta multiplied by sin theta equals to F. Now we know that sin theta divided by cos theta is tan theta. Then we can write mg tan theta equals F. mg tan theta is first answer. Answer 1 is correct for the question number 13. Then question number 14. Two equal masses A and B are attached to a light inextensible string passing over a smooth light pulley as shown in this diagram. The mass B is moved down, held it stationary and then released. Which of the following statements is correct for the subsequent motion of B? In this question, there are same masses. We have to consider it first. There are same masses. If there are same masses in both ends, then moving a mass in downward direction. Like this. Now there is an equilibrium because of, for this point, mg equals mg. For this point also we can consider mg equals mg. This weight is moving downwards and they have clearly given that the mass B moved downward, held it stationary and then released. Held it stationary because of the system is in an equilibrium. If the system is moving, it will move continuously because of there is no an external force, external unbalanced force. There are two equal forces, but in the question it held it stationary and then released. Therefore, it will not move. A and B will stay stationary, but we have to consider only the motion of B. B will stay stationary. Third answer is correct for the question number 14. 15. A weight W is hung on a tight fixed rope as shown in the diagram. The tension of the rope is. They have given that hung tightly. Hung tightly means we can consider that it is in horizontal plane. It is horizontal. But I will draw a diagram like this. We have to consider what happened when the rope is horizontal. I will consider this angle as theta and tension for both ends T, base is W. Now we can consider the vertical equilibrium of this point. When considering vertical equilibrium, we have to get component of tension. Now in upward direction, tension component T cos theta, and there are two values because of this tension and this tension, and horizontal components T sin theta and T sin theta, cancelling because of equal and opposite forces. Now there are only two forces, 2T cos theta equals downward W. Then I will subject tension W divided by 2 cos theta. W divided by 2 cos theta. Now consider that they have given the string is fixed tightly. Therefore, theta approximately equals to 90. When theta 90, cos theta equals 0. Cos theta 0. Therefore, T should be equals to W divided by 2 into 0. T equals to W divided by 2 into 0. It means we have to divide by 0. Tension should be infinity. Infinity means a greater value. Therefore, tension much greater than W. Answer 5 is correct for the question number 15. Then question number 16. A uniform bar of mass M is suspended from its midpoint by a spin balance. Two masses M1 and M2. M1 is greater than M2. Are placed at two ends of the bar. A wedge supports the bar at the end B. Keep it horizontally as shown in the figure. The reading of the spin balance is. They have given that M1 is this way. M1 is greater than M2. We have to get the tension. Tension means the reading of the spin balance at this place. Then M1 is greater than M2. It means if there are forces, they have given that mass of bar is capital M. Capital MG, M2G, M1G. I will mark forces M1G. Then M1 is the greater value. M1 is greater than M2. If M1 is a greater value, there is a torque, there is a resultant torque in this direction. The system is trying to rotate to this direction. But they have given the supportive wedge is at this place. supportive weight at this place. I think that it could not be at an equilibrium. We know that if M1 greater than M2, there is a rotation in this direction. Therefore, supportive weight should be at this place. Therefore, I think that the direction of this inequality sign should be opposite, like this. M2 is greater than M1. Now we can consider the supportive edge is at this place. And when considering resultant torque due to M1G is in this direction, M1G into L over 2. L means length of the rod, L over 2, torque around this point, O point. Torque around O. In opposite direction, torque around O, M2G into L over 2. Now, there is a difference. M2 value is a greater value. Therefore, difference of torque, I will consider it as delta torque. M2G L over 2 minus M1G L over 2. For the equilibrium, this resultant torque should be equal to torque given by wedge. Then we can write M2G L over 2 minus M1G L over 2 equals to the torque given by the wedge's reaction into L over 2. We have to consider torque around point O. Now we can cancel out L over 2 for all terms. Now reaction is M2 minus M1G. It is the reaction. But we have to get the reading of the spin balance. Then we can consider vertical equilibrium. There is a tension in upward direction. We have to find the tension and reaction in upward direction. Tension plus reaction in upward direction should be equal to M1G plus M2G plus capital MG. Capital MG means weight of the rod. Then we have to find the T value. M1G plus M2G plus Mg minus reaction is this one. M2G minus M1G. We have to subtract it. Then I will simplify. M1G plus M2G plus Mg minus M2G minus M1 minus into minus plus M1G. Now we can cancel out M2G. The answer is 2M1G plus Mg. 2M1G plus Mg. Correct answer is 4 for the question number 16. Then question number 17. A bolt of mass M sits on a tightly stretched telegraph wire as shown in the figure. The additional tension produced by the bird in wire is same question like 15. We know that it is more than mg. More than mg. Again you can use the theory of question number 15. More than mg means third answer is correct answer for the question number 17. Three masses A, B and C are hanging from a horizontal crossbar as shown in the figure. Each crossbar has a negligible mass. If A has mass 6 kilograms masses of B and C respectively are. Now we have to consider the equilibrium. I will draw a rough sketch. This distance is x and this distance is 3x. A. Mass of A is given as 6 kilograms. Then 3y, y. This weight B, this weight C. Now we have to find the weight of B and C. First of all, I will consider torque around this point. Torque around point O. Mass of B multiplied by perpendicular distance y should be equals to mass of C multiplied by 3y. We can cancel out y term. B equals 3C. Then we can consider torque around this point O dash. Torque around point O dash. 6 into x equals to, in this reaction, B plus C is the total weight from this point into 3x. Now we can cancel out x term. We can use B is 3C. 3C plus C times 3. We can find the C value. 3 divided by 3, 1, 2. Now C plus 3C is 4C equals 2. C equals 2 divided by 4. It means 0.5. Mass of C is 0.5 and we know that B is 3 times C. Therefore B is 1.5 kilograms. 0.5 and 1.5. Then answer 2 is correct for the question number 18. 19. Figure shows an attempt made by a man to hold a bull tied to a rope trying to escape. The forces X acting on the bull's leg FL and acting on the ground FG. The forces at Y acting on the rope is FR and that on the hand of the man is FH. The forces FL, FG, FR are correctly represented by. We can consider point X. When considering point X, the force given by the bull on ground is in this direction. It is given as Fg. Force on the leg is in this direction. Fl. Equal and opposite. And at point Y, force on rope is in this direction. Force on man is in this direction. Force on man. Right. Then we can get the second answer is correct answer for the question number 19. Question number 20. Figure 1 shows a book A placed on the top of a box B, which rests on the floor. Figure 2 shows the free body force diagram for the box. P, Q, R indicate the forces acting on the box. Which of the following statements is true? In first one, they have given Q is greater than P plus R. It is false. For the equilibrium, Q should be equal to P plus R. Second one, force on the floor exerted by the box is indicated by P. No. Force on the floor should indicate by as the reaction from the box to floor. Now there are three forces. Forces are acting on the box, not floor. It is incorrect. C. Force on the floor exerted by the box is indicated by Q. Yes, it is correct. Force on the box by flow is reaction. It is indicated as Q. Then answer C is correct for the question number 20.